Hi, my name is Evan Wozniak, and this is my video submission for ENME435, homework number 4. So the first thing I'd like to talk about is how I differentiated between the right lanes versus the left lanes. So in order to do this, I leveraged the fact that the actual lane lines tilt inwards at different angles, at least from the viewpoint of the camera. So in my actual code, when I collected row and theta values from the Huff lines, if the theta value was greater than pi over 2, based on the tilt shown in the video, I sorted those row and theta values into an array of right row and right theta corresponding to the right lane. Otherwise, I separated, if theta was not greater than pi over 2, I separated those row and theta values into their own array corresponding to the left lane. In terms of plotting, to get two different colors, I had to create two different functions, plot right Huff lines and plot left Huff lines. Structurally, these functions are exactly the same as the module that we did in class. The only difference is that plot right Huff lines will plot the right lane in the color red, and plot left Huff lines will plot the left lane in the color blue. So beyond the module that we learned in class, I had to add a few modifications in order to optimize performance for the first video. So one issue that I ran into when running my algorithm on the first video was that the brakes in the left lane, because the left lane is dashed, it resulted in a failure to pick up row and theta values whenever the frame had a break in the line. And I was encountering this issue mostly for the left lane, but occasionally for the right lane as well. So in order to remedy this issue, I created two arrays, left temp and right temp, and these two arrays are responsible for holding the row and theta values of the most recent previous detected line. So in my code, these four lines are tasked with remedying this issue. And so my logic was that if row and theta values were not picked up, my algorithm will simply just use the most recent previous ones. My logic behind this is that since lane lines are straight, there shouldn't be much change for row and theta values between video frames. So if one frame I can't detect row and theta values for the left lane or the right lane or both, I should just be able to use the previous frame's values, and there shouldn't be much of a drop in accuracy. The rest of my detection pipeline remained largely the same from the module in class, besides these changes that I mentioned. So now I'll show my performance on the first video. And as we can see, we get the left lane in blue and the right lane in red. And the lane lines are pretty accurately overlapping where they should be. I will say the lane lines have a tendency to look like they're jumping around a lot, and that's because new lines are plotted for every single frame of the video, which creates a lot of shakiness in the lines themselves. Now, this performance stays largely consistent for the rest of the video's duration, so I'm going to go ahead and end it now. So now, going on to the second video, which I'll load in. I did have to make some further changes in order to optimize performance. So one issue I ran into the second video was that there were lighting issues. So the sun in the second video was a lot brighter, which made picking up the white lane lines harder. And so the original color thresholds weren't accurate for optimal performance in the second video. The original thresholds simply were not allowing the algorithm to pick up the lines at all. So in order to remedy this issue, I created two new thresholds for both white lower and white upper that are only to be used for the second video. So go ahead and comment out the first video's thresholds and bring in the second two. The other issue I had was that the new camera position present in the second video also meant that the plotted lines were not in the correct position. They were parallel to where they should be, but they weren't overlapping. So in order to remedy this issue, in both plot right huff lines and plot left huff lines, I had to change the X and Y offsets. So I have special X and Y offsets that only are applicable to the second video. So these first two rows are for the first video, so I'll comment them out. And then I'll bring in the offsets for the second video. And I'll do the same for plot left huff lines. And other than that, the rest of my algorithm remained largely the same. So I'll go ahead and show my performance on the second video. So as you can see, the lines are pretty close to where they should be. We do see that this left lane line is jumping around a lot, and sometimes this right lane is too. Sometimes at angles that are pretty far off from where they should be. And I think this is due to the still color thresholding issues. I think the algorithm is still having a hard time picking up the white lines on the road because the colors are pretty similar. And so it's having a hard time differentiating between the lane lines themselves and the actual road. And as we can see in this part of the video, the shadow from the car in the adjacent lane is also posing an issue. It's making it hard to pick up the left lane. And this performance is largely consistent for the rest of the video, so I'll go ahead and end it. So in terms of recommendations, I have two main ones. So software-wise, I would next time average the row and theta values across multiple frames to get smoother lane detection. We saw in both videos the plotted lines had a tendency to jump around a lot and look very shaky. And I think this was because I was plotting new lane lines for every single frame of the video. If I average row and theta values across multiple frames, I should get smoother lane lines in general ones that jump around a little less. And then hardware-wise, I would recommend just having one consistent camera position. We saw that I had to change the X and Y offsets between the first video and the second video because the position of the camera changed, which resulted in the lane lines being positioned differently in the video. And then secondly, I would recommend possibly a better camera that could maybe provide clearer color imaging so that the algorithm could more accurately pick up the colors and that things like the sun wouldn't affect the color thresholds as much. But yeah, those are the two recommendations I have. Thank you.